Great to be back. And this time I have a pretty hands-on walkthrough of DigitalOcean. So in the next 45 minutes or so, we're going to see how we actually migrate an app from our dev environment to the cloud and exploit some of the capabilities of DigitalOcean in tweaking this application and going live, right? So I know we have taken the poll right at the beginning, but how many of you use DigitalOcean today? Okay, that's quite a few. So how many of you are developers who write code? Fantastic. How many of you are administrators or ops guys? Okay. How many of you are neither, which basically means you are managers? Okay, there are quite a few. Awesome. So this session is going to appeal to everyone, whether you are a developer, you are an ops guy, or you are a manager who manages some of them. So let's get started. So this is very light on the slides. You are able to see my screen. Okay. So this is going to be very light on the slides. I just have 4 slides, but it's a hands-on walkthrough. So let's get started. The very first thing that I want to show you is a portal called Cloud Shop that I'm currently running on my local host. And our objective is to move this to the cloud, and in that process, make it more secure, more reliable, more scalable, right? So let me switch to the demo. So here, what you actually see is the portal called Cloud Shop. And if you notice, it's running on my local host, port 8080. I'm running Vagrant with VirtualBox. Everything seems to be perfect. It's an e-commerce portal that I'm going to launch globally. Incidentally, my first market is going to be US. I'm going to target the US East Coast customers. So let's actually take this portal and run it on DigitalOcean. So what you see here is my dashboard, or the portal, or the console of DigitalOcean. And those of you who are seeing this for the first time, you'll actually notice that this is very, very simple. This is the minimalistic user experience for you to get started with cloud. So, and those of you who are already familiar with DigitalOcean, you will notice that I don't have any droplets. I don't have anything configured. So let's do a fun thing, right? So I'm going to pull up my stopwatch, and I'm going to click on the start button of my stopwatch, and let's start counting, right? And from now, I'm going to start my migration process. So I'm going to click on create droplet, and this is going to give me multiple options. So I see a set of operating systems, and I'm going to choose Ubuntu 14.04, which is my operating system, and then I choose one of the powerful configurations that comes with 2 GB, 2 CPUs with 40 GB of SSD. I choose that as my configuration. Then I'm going to choose New York 1, which is going to be where I'll be actually launching all my servers. And I'm targeting US customers. So it makes perfect sense for me to go live in New York region. And then I also enable other options like monitoring, backups, completely optional, but I would love to monitor my droplet. So I'll enable that, and then I add the SSH key that is pre-configured with my account, and let's call this web1, right? So that's about it. Choose your OS, choose the config, choose the location, attach an SSH, go live, right? So now the droplet is getting created. In just a few seconds, we'll actually get access to our newly minted virtual machine. And this is going to be extremely fast. It just takes a few seconds, and we should get the IP address that we can use to SSH into our box. So there we go. It's almost done. And that's about it. So now I'm going to grab the IP address of our portal, of our VM, the droplet, come to my command prompt, and SSH as the root user into my droplet. Okay, so now we are in our web1 droplet running in New York 1 data center, and I have some scripts that I want to run. So The very first thing that I'm going to do is to install the Git client, because some of the older Ubuntu operating system images didn't have this. So we installed Git, and then I'm going to clone my repo, which is running the Cloud Shop source code, which is actually hosting the Cloud Shop source code, and we are done with that as well. Then I go ahead and execute a simple script, which is going to configure my web server. So I'm going to run this command called setup cloud shop, and for that I need to pass the public IP address of my droplet, because the shell script wires this IP address with my portal, which is required to go live. So now I run this command, and for those of you who are sysadmins and know what is going on, we are basically configuring the LAMP stack on Ubuntu 14.04. So this is going to install Apache, PHP, MySQL, and do a bit of configuration required for our portal to go live. So, thanks to the powerful box that I launched, that's sufficient enough for me to go live. So let's give it a minute or two, and very soon we'll actually see Apache getting configured, PHP getting installed, and it should be done. Okay, another minute or so, we should be able to hit our portal. Okay, now MySQL is installed and it is getting started. And now it's turn off Apache, so everything should be done. And that's about it. So this entire process takes exactly a minute, not more than that. And once we see the command prompt again, let's go ahead and test it out. So now we are done. So let me grab the IP address, go back to my other browser, copy and paste this, and there we go. Cloud Shop running in the cloud. And let's look at the stopwatch. Okay, so it just took us roughly 4.5 minutes to move our portal from the local host to the cloud, right? Now, I wouldn't be able to do this demo in any other platform. Maybe by now I would have just launched my first VM, right? So this is what I like personally about DigitalOcean. It lets you launch a VM in lightning fast mode, and then you are able to configure it end to end. So in roughly about 4.5 minutes, we are able to move our dev environment into production running in the cloud. But that's not all. So let's come back to the slides and take a look at this. So this is what we have achieved in the previous step. So we have Cloud Shop, and the current deployment looks like this. So we have one droplet that's running both web and the database, and it is pointing to the IP address. Optionally, I could have attached what is called as a floating IP, which is a static IP address that I could associate, but this is not the only droplet I'm going to run, so I will not attach an IP address at this point. But is this the best way of running an e-commerce portal? What is the glaringly visible issue with this deployment? It's a single point of failure. That's because I'm running both my web and database in the same VM. If this VM crashes, we lose everything, right? Our shopping cart, our customer data, current sessions, everything will be gone. So what we're going to do in the next step is to separate the database from the web, right? This would make our deployment slightly more robust and avoid single point of failure. So in the second mode, even if the web server dies, we have the database available. So we can bring back another web server and very soon go live or get back to action when we face any disruption. So let's actually go ahead and do that. So it's time for me to launch another droplet, right? So I'm going to create a new droplet, but I'm not going to show you all the steps again. So this time, of course, we're going to choose another Ubuntu box, same configuration, and NYC1 is the location. And I'm going to introduce you to a concept called user data. So basically, all the steps that I have performed here with manual copy paste, I can pretty much run it at the boot time. And that's what I'm going to do with user data. So when I actually click that checkbox and enable user data, I can pretty much run a shell script that would automate the configuration. So what we are essentially achieving at this step is we are launching a new droplet and also configuring it in the process. So by the time the droplet is deployed, we actually have MySQL completely installed and the database imported into it. That's the step that we are taking here. So pretty straightforward. The only difference is we are using what is called as user data, and you can pass any bash commands to this. Now this includes, for example, cloning your GitHub repo, invoking the setup script, or pulling your repositories or Docker images. Anything that you want to execute right at the boot time is what you run inside the user data box, right? This is very popular. It's also called cloud config. Ubuntu started that, and eventually it is supported by every cloud provider, including DigitalOcean. And this is a lifesaver when you want to automate your deployments. So this gives you a hands-free way of configuring your VMs. So let's go ahead and run this. I'm going to call this as db1, right? And we are going to launch the second droplet. So now what we are actually trying to achieve is to separate the database from the web to make the deployment slightly more robust. I'm not saying this is foolproof, but we are better off decoupling the database from the web. There are many other knobs and switches that you can turn on and turn off or dial, but due to the time constraints, I'm showing you the higher level options that you may have. That's it. Now we have the database droplet. We're going to try SSH into it. Okay, so this is going to take slightly more longer because remember there is a background process that we initiated that's going to kick in, and once we have access to this, the best thing is MySQL is already up and running, or it would be in the process of getting set up. So let's check the status, service MySQL status, and this is currently in stop mode, which means it's just installed. Now we are going to check again, and very soon it should move to start. So let's give it, there we go. So now this is starting, right? And this is an indication that MySQL is up and running inside this droplet. So now I got to do one thing to ensure that the deployment is complete. And what is that one step that is left in this configuration? Pointing my web server to the database, right? So at this point, I want to introduce you to a very simple configuration file that I maintain, which will take care of my configuration. So that's called config.php. And inside this, you'd actually notice I'm currently pointing MySQL to localhost. So let's actually do this. Now we are still able to access Cloud Shop. Everything looks good. All I'm going to do is stop MySQL on my web server because we are not going to use it anymore. And now let's do a refresh. And that's broken, right? It's an indication that the web server is not running the database anymore. The local host doesn't run MySQL. So that's the reason why you see a broken portal. Now I come back and fix this in my configuration file. So in the configuration, I'm going to replace localhost, which the web server was talking to the database through this connection string. And I'm going to get the IP address of our database server, paste it here, and come back, do a refresh. Okay, now it's back in action, right? What did we achieve now? So now we have a two-tier architecture. The first tier is the web tier, the second is the database tier, and we just established connection. And this is far better than the initial single point of failure that we had to deal with, right? Are you with me? Excellent. So let me take you back to the slide deck, and let's let's do a quick check on where we are in terms of the deployment. So this is where we are, but there is still a lot of room for improvement, right? For example, what happens if my database server dies? That's pretty risky. At this point, I want to take another step, and that is moving the database to block storage, right? So what is block storage? So block storage is basically a storage device available to you in the cloud. You can attach that to a droplet, and when the droplet dies or when the droplet terminates due to some reason, your data that is persisted on the block device is still available, which means when we actually move MySQL to this droplet and we move the log files and the data files to the block storage, we are making it much more reliable, because if something goes wrong with our droplet, we can launch another one and quickly mount the same volume, same block storage device, and our database is back in action. So we are now bringing another level of decoupling between storage and the compute, right? So let's actually go ahead and take a look at the configuration required for attaching a block storage, right? So we are back to the console, and I click on volumes, right? So here, when I look at the volumes, there is already one. Actually, let me get rid of this, because this could be the previous one from my dry run. So now we don't have any block storage volume, so I'm going to go ahead and create a block storage volume. I just need about 10 GB because we are pretty early in the business, so we don't need anything, and this would just cost me $1 a month, which is pretty affordable. And here I'm going to choose the droplet, which is DB1, right? So this step is now associating the block storage device that we just launched with the droplet, which is DB1. And it throws a pop-up which will guide us through the process of configuring. I don't need this. And now when we actually come back to the droplets, nothing changes. Now all I'm going to do is to come back to my DB1 and run a script. So in my OPT Cloud Shop folder, there is a database script. So I'm going to basically execute that. So here there is a command called setup wall. I'm going to simply run this. And what this does is it's going to take our external block storage device and format it, move MySQL database and logs to it. So let me go ahead and run this command. And this is going to take just a few seconds, and it essentially takes our volume, formats it, relocates the log files and the data files of MySQL, stops the service and restarts so that it picks up the new location. So now when I actually go to cd wall, you will notice there is etc, lib, and log directories. This is coming from MySQL. And the /wall is nothing but a block storage device that we just attached. In case our droplet crashes or dies, nothing happens to wall. It is going to be up to minute, because every log, every transaction that MySQL commits is going to be written to this directory, and this directory is not an integral part of the droplet. That is the beauty of block storage, right? So now we have everything in place. Let's check if our portal still runs, and this is still running, which means it is more reliable, more stable, and it currently runs with this architecture where we have the web server running in a different droplet, database running in another droplet with a block device attached to it. But that's not all. We can actually achieve better scale by launching another web server, right? So now I want to really take this to the next level, where we want to handle the load and the traffic that's going to hit our portal. Let's say we launched a campaign, and this campaign is driving a lot of traffic, right? Maybe Samsung S8 is going to be exclusively sold through a pre-ordering mechanism. And we are seeing tremendous traffic hitting our cloud shop, and it's time for us to launch another web server. So am I going to repeat all these steps? Not exactly. I want to show you another best practice that you can derive within DigitalOcean. So once you configure your web server and everything seems to be working, you can actually take what is called as the snapshot. So if you click on the droplet that's running, you can come to snapshots and take a live snapshot. And because we are not running any transactions and there is no writable file system, it is completely stateless, we can take a live snapshot, which means while the web server is still running, we're going to capture its state, and this results in a new image. So when I actually come to images, you'll notice that my perfectly configured web server has been turned into an image, and I call it web gold. So that is my gold image. And subsequently, anytime I want to launch a new web server, I can basically launch this, and it comes fully configured except two parameters. The first parameter is the IP address of the web server itself, and the second parameter that it doesn't know is the database. So for me, this is going to be as simple as launching this image, which is coming from a pre-configured web server, and modify those two settings, and boom, we are good to go. So let's actually go ahead and launch this. So I choose web gold and create a new droplet. So this time I never have to do a git clone, I never have to run the setup script because it is picking up from the existing configuration. So this is the configuration that I'm going to use. It's going to be launched in NYC1. Enable monitoring as a best practice, and let's call this web 2, right? So now we are going to end up having a fully configured droplet that's capable of running Cloud Shop. So now we are moving into a slightly better architecture where we have two web servers and one database mounted on block storage. So this is how production applications are typically deployed. Again, by no means this is the most complete deployment, but this is far better than running everything in one droplet. This is going to take slightly longer than launching a plain vanilla Ubuntu or a plain vanilla image, because it's actually doing it from a custom snapshot. It is converting that into an image, and then it is going to launch this. So it's going to take slightly longer, but the benefit of this, the advantage we get, is we finally end up getting a fully configured droplet. So now let's SSH into this. Okay, and let's check for the existing files. So it should have var w3 HTML folder with fully configured portal, and we just need to update a couple of parameters. So let me go to var w3 HTML, and here we actually see a set of config files and PHP files, which means the droplet is fully configured. So now I'm going to open config.php and update a couple of parameters. The first one is it is pointing to a wrong IP address because we didn't know what is the IP address assigned to this. So first I'm going to grab the IP address of web2 and paste here. Same thing I need to do for HTTPS to make this work. And then the database is pointing to something else. So I need to update this as well. So let's get rid of the existing database connection string, and we'll point this to db1. All right. Let's ensure that everything is fully configured. So I'm going to restart Apache just to ensure that we have configuration becoming effective. So now let's grab the web2 IP address, come back to our other browser, and this should show Cloud Shop, right? So this is now a 2 VM deployment talking to a database mounted on block storage. Is this better? Absolutely, right? Because if web 1 knocks off, we have web 2, and there is redundancy, there is better availability of our applications. But we are still not completely done. The challenge is, how do I route traffic to one of my web servers, right? So now we are currently at this stage of deployment, right? So this is what we achieved in the last step. So it is basically two web servers, each of them having an IP address, and then there is a database droplet based on the block storage. Now I want to introduce a brand new feature that just got launched a couple of weeks ago, which is the load balancer. So now what we'll actually do is wire up both the web servers to a load balancer and route the traffic alternatively using round robin to both the web servers. So let's actually go ahead and do that. Now we come back to the console. Let's look at networking tab, and here you actually see load balancers. So when you actually create a load balancer, you have multiple options. You will start with the name of the load balancer. Let's call this test load balancer. And then you type the name of the droplets that we created, and the load balancer is automatically selecting the region. Because we are running our droplets in NYC1, obviously the load balancer is also going to be in the same region, same data center. So once we configure that, then we point load balancers port 80 to the droplets port 80. This is a no-brainer. We are basically doing a pass-through from the load balancer port to the actual droplet port. And if you are interested, you could also edit additional configuration. For example, do you want to route the traffic to the web server with least connections, or irrespective of the traffic, do you want to always do a round robin among existing web servers? Sticky sessions is to ensure that your request always goes back to the server where it originated. It's not recommended, it interferes with the scalability, but a sticky session would always give you some kind of an affinity with the backend web server that you're talking to. And then you can also define health checks. So a health check of the load balancer will make sure that it is checking the ping response every 10 seconds, right? So if the web server is healthy, what is the HTTP code that you would see? 200, right? So the load balancer will check for HTTP OK every 10 seconds, and it would wait for a few thresholds, few retries, at least 3 times before it actually marks the droplet unhealthy, and it will stop sending the traffic. So that means if one of the droplets faces an issue and it is not responding with HTTP 200, load balancer can become your first line of defense, and it can start routing the traffic to the healthier instance than the faulty one. So this will give you, again, fault tolerance right at the load balancer level. And finally, if you want to enable SSL, you could actually use this, redirect HTTP to HTTPS. But before that, you should have configured a HTTPS port that is talking to port 80 of your web server, so that you can basically turn all your insecure requests into more secure requests. So this is going to take a while. To save time, I've already gone ahead and created a load balancer called shop LB, and it already acquired an IP address. So now what we're going to do is to configure this with our droplets. So currently, if you notice, there are no droplets associated with the load balancer. So now I come back to this, click on edit settings, and add both our droplets that we are running. So let's choose the droplets, web 1, web 2. Now what happens if I launch another droplet? So it could be tricky for you to run through this process of manually adding your droplet to load balancer. Instead, you could actually create tags for your droplets. For example, you could have created a tag called web, right? It's a metadata that you associate with every droplet. And now you can create a tag here called web, and the best thing is anytime you launch a new droplet that matches this tag, the load balancer will start routing the traffic. So that will relieve you from the manual configuration of adding droplets to the load balancers. That means anytime in the future, when you keep adding new droplets that matches the tag, load balancer will auto detect, it will discover, and it will start routing the traffic. This is again a wonderful capability, wonderful feature for DevOps, because with user data and with a bit of automation, you can seamlessly expand and shrink your deployment without ever manually configuring the load balancer. So for now, we are manually adding the droplets. So, oops, I don't think I added the other droplets. Let me also add web 2. So now we have added both the droplets. It still says down because it will take a few seconds for the load balancer to register the droplets, because it's going to do a ping based on the health check that we configured, and only after that response with a 200, it will become healthy. So let's give it a few seconds, and very soon we should see a healthy status. So we have gone through these configurations. So currently everything seems to be in place. So we just need to ensure that both our droplets are now registered with the web server. And this is going to take slightly longer depending on the configuration and so what really delays this? It's pretty simple. So we have the health checks enabled, and these health checks will kick in after all these parameters are completely met. So that's the reason why the initial warm-up time it takes is going to be slightly longer. And now both the droplets are reported to be healthy, right? Now what we're going to do is, I actually have a third-party service that I use. Let's actually bring that up. So I'm going to use a third-party service called DNS Made Easy. So what does it do? It basically associates a domain with my portal. So I'm going to log in to this third-party service called DNS Made Easy, and all it does is to basically wire up a domain called cloudshop.in with the load balancer's IP address. So now we take the load balancer's IP address and point it to a domain that we have here, which is called cloudshop.in. That's the only step that I am showing here. So now we have a domain name that is wired up to the load balancer's IP address, and the load balancer is pointed to the actual droplets. So everything should work, but there is one final thing that I want to achieve. An e-commerce portal is not trustworthy till it becomes secure. Currently, if you look at our portals, this is not secure. Your connection to this site is not secure. So this is a big flaw in my deployment, because my customers won't trust if I don't show a green tick mark, essentially highlighting that it is a certified, it's an SSL configured portal, right? So let's make our portal secure. So for that, what I'm going to do is to come back to the settings and do a couple of more configurations. The first thing that I'm going to do is to add a HTTPS port, right? So 443, and it is going to be terminating at the load balancer. So we are going to attach a few certificates right at the load balancer level, but we'll leave the web servers independent of SSL. So this is called SSL offloading, where you are moving the burden of SSL termination from the web server to the load balancer. And here we are going to create a new certificate. Let's call this demo SSL, and you need to just pass the parameters, or rather copy paste the certificate details. Again, how you acquire these digital certificates is completely up to you. You could actually go sign up with VeriSign. You could go pick it up from any certificate authority. But if you don't want to spend, you could also use Let's Encrypt to create self-signed certificates. That's what I have done. And showing you how to create self-signed certificates through Let's Encrypt is out of the scope of this demo. You can look up for some documentation tutorials published on DigitalOcean. But I have followed the same process to essentially create my certificate. So what I'm going to do now is to grab those certificates and quickly associate that with my portal. So now, let me open them in a new window so it becomes cleaner. So I'm going to first start with the cert. So this is the certificate that I'm going to associate. So I will paste this here. And then I also need to get my private key into the load balancer. So this is my private key. I'm going to paste that here. And finally, I need to show the full chain as well. So I'm going to grab that and paste it in the third text box. So this step is essentially helping us with securing our deployment. So we are terminating the SSL at the load balancer level. So now I'm going to say save SSL, and that is done. Now I can safely come back and actually forward every HTTP to HTTPS. So redirect every HTTP to HTTPS. I'm also going to enable this, which will help us by default turn the HTTP into HTTPS. That's all. So now finally, I just need to perform one thing, which is update my configuration with the new domain that we just secured. So for that, I need to run a couple of commands, which will look something like this. So we have the individual IP addresses of our droplets lying in the configuration files. We are going to replace that with cloudshop.in. So now I'm going to go back into my web 1 and run this single command. What this basically does is it's going to update my HTTP server and HTTPS server with exact details with the domain, which is the final step of our configuration. Now I pretty much do the same thing, but before that I need to grab the IP address of the web 2 because that's what we want to replace. Get rid of this IP address, paste it, and replace it with HTTPS cloudshop.in. So now when we run this, let's also cross check if this is updated to HTTPS, and there it is. Now the final moment where we actually type cloud-shop.in, and if everything goes well, wow, okay, this is not something that I expected, but this should be done. Okay, someone is clicking photograph of the shark. Okay, so the shark greeted us briefly before we could actually access the portal. So now if you actually notice, there is a little bit of lag because the entire configuration is getting applied. So now, do you notice the secure thing here, which is basically indicating that our portal is now SSL enabled, and we are able to, one of the sites, one of the droplets seems to be, okay, so now we are almost done, but what is the proof that the traffic is actually getting routed to both the servers? So what I want to do is update the logo. So what I'll do is on the first box, web 1, I'm going to replace the logo with a logo that actually puts a 1, and I'll do the same thing for the second one as well, right? So now when we actually come back and do a refresh, there seems to be some issue with the deployment, but so in a few seconds, you'll actually notice that the traffic is going to get routed to either of the boxes, and you would notice a change in the logo, right? But unfortunately, I don't have enough time to debug it, but you get the idea. So this is the outcome that I wanted, where we have a HTTPS enabled load balancer talking to 2 different web servers, and the web servers are talking to a database droplet, which is in turn using a volume, a block storage device, which actually makes our deployment very, very production ready, and this gives us much better scale and reliability. What I could also do is to add a master slave configuration to my database tier. So that would make it much more reliable and fault tolerant, because if one database server dies, the other one would take over. But you can do many other tweaks. Like I could actually create a session server, move the sessions from web to that, maybe run Memcache or Redis. So as I mentioned, the number of knobs that you can turn, the number of sliders you can drag, there is no limit. You can actually take this deployment and make it much more fault tolerant, much more reliable. But at this point, we are far better than running everything in just one VM. And the objective was to highlight a few capabilities of DigitalOcean, which is basically the block storage, which I have demonstrated, and the brand new load balancer, which is now helping you with both SSL termination as well as round robin or least connection based algorithm. So that brings us to the end of this demo. Thank you so much for sitting through and patiently looking at all the code and the deployment process. You have my coordinates. If you have questions, feel free to drop me a note. Due to lack of time, I'm unable to take questions. But this has been great fun, moving from localhost to the DigitalOcean and going live with it. You can actually access cloudshop.in from your mobile phones and connected devices, and you'll actually hit that. I'm going to leave that for a while just to give you access, and you can test it out. So thanks once again. Thank you so much. Have a great conference ahead. And drop me a note if you have any questions. Thank you.